Okay, got everything on the bench here. The first issue I've got to deal with is the very inappropriate power plug here. This guy. So this is the plug that goes in the socket here, coming over from the power supply, but this is really just straight to the plug that goes in the wall. So the way this works is you plug in here, and power is delivered to the motor through here. So what I would intend on doing is cut this off, remove this wire, take a look at this wire. I don't think we can use that anymore. Pull the wires out of here, attach them there, presto, we're done. Is there a polarity issue here? Is there a polarity issue here? Probably not. The power wires probably make no contact with the chassis part. So this green wire, which is hooked up to the chassis, is quite independent. Probably doesn't matter which way I put the wires on here. But what I can do anyway is after hooking this up, I can just take my voltmeter and double check to make sure there isn't 120 volts sitting on that chassis, which I just don't think it can happen. But so I'm going to go ahead and put this cord on, put this plug on that cord. Very good. Well, it took quite a while to get this to go in here. These are not easy. You know, they're easy when they're new, but not when they've got a wire in them. So I'm kind of trying to clean off some of the excess solder that ended up on the outside. Yeah, it took a long time to get those wires set in there. Okay, that should be good enough. Let's check it out. Yeah, goes in fine. Perfect. Okay, we're just about ready here. Just about ready. Gotta pick a nice record. Okay, so I think the next prudent thing to do is a little safety check here. So I'm gonna plug it into a regular outlet for the first time. Switch is off. Got my voltmeter ready here. I'm going to look for any 120 volt voltage on the chassis here or here or just here and there, just to be absolutely sure. I'm going to plug this into a regular outlet power bar, in fact. Okay. Now here we go. We see something like 50 volts. That says one thing. It's 120 that I'm just checking around. Here's 10. Let's go right on the chassis here. 10. That's not a problem. I'm going to switch this on. Oop, the knob come off. Okay, it's warming up. Let's check now. Okay, so we're seeing 60, 70 volts. That's not really a problem. We are something similar, and probably up here the same thing again. Actually, less up here. Is this really getting power? We'll flip this onto manual just to get the motor going. Oh yes, definitely getting power. Check again. There's a green wire that runs from here to the chassis that's not connected yet. So these are voltages that are developing because of capacitive interaction of things. Not much more than that. If this went to 120, yikes. 0 is nice, but okay, we're good. I'm going to pull the plug out here. There we go. Pass the safety check. I did put a polarized plug on here. It only goes in the outlet one way, so there's no need to check it this way and that way. Good to check it off and on though. Have it both off and on. Let's get this meter out of here. Good. I also didn't plug in the audio cord because I'm trying to maintain separation. We'll plug in the audio output line here. There we go, and we will hook up the green ground wire. There's a connector on the back of this power supply. There we go. We are ready. Now I did not go and get a good record at this point. I'm still going to use kind of a crummy record. Oh, look at that. Alice Cooper. Isn't that something? Yeah, I love this record. I'm 18 and I don't know what I want. So again, I can't just play this or I'll get a copyright hit and my 50 cents will be lost. So I'm going to have to fiddle with the volume up and down. Now what we're doing, checking the whole system to see if it operates. Let's put this onto phono. Now is that phono high or is that phono low? That would be phono high. So it just says treble and bass. It's in the treble position. I don't really know for sure what that means. I'm going to plug this into a regular outlet again. And what we're trying to find out is this loud enough? That's the first question. How does it sound? Is it loud enough? Okay, plug it back in. There we go. Left that on manual. Shame on me, right? That's what you're not supposed to do, is leave the record player sitting still with it still switched on, because the idler, the intermediate wheel, will be pushed up against the motor. This is on too. Okay, we'll give it a moment, make sure it's warmed up. See if we can hear any hum at all. Stick my ear in the speaker here. Oh, jeepers creepers, that scared me. That was nothing. Just something to wake everybody up. A little bit of hum there. I'm going to vary the volume and listen. Wow. That's not the best. So that sounds like the cartridge is open. That sounds like this cable's not connected. Kind of hard to see how that could be. Let's give it a go. We're also curious about the speed of this, in case it may not be quite correct. Okay, volume. Does sound a little slow. Does sound a little slow to me. Caught in a dream. He's 18. He doesn't know what he wants. He's got to get out of that. Okay. Lots of volume. I didn't turn that up very loud. Doesn't sound very bassy. Partially because of the record, perhaps. Mostly because this is not in the cabinet. Well, let's flip this tone switch. In fact, let's do that. Let me put this back on. Okay. Bass. So it sounds like what's really going on here, and it would be surprising, is when it's in the treble position, all the signals coming through. When you flip it to bass, it depresses the treble a bit. It doesn't really bring up the bass. A long way to go. Yeah, I had a long way to go since I used to listen to this record. I've gone a long ways. Okay, so no particular hum. Why did we hear that sound? That sound. I don't want this flying into the... Strikes me that the shielding's not great. Maybe it's these wires over here. There's unshielded wires here. So a good question is, what's with all this wire here? Why isn't this shielded cable fed right up into the connector up there, which would be a better deal? And what if we put a better shielded wire on there? So I think that's probably what I'm going to do. Let's turn it off here. Let's turn this off. Make sure it's out of contact. Lovely. Lock this in so I don't mess it up. So I think I'm going to replace this with a better piece of cable and get rid of these wires. We'll connect it right up tight. Then the only portion of unshielded wires is this is metal here. Just a little bit in the back here, a little bit. These are all kind of shielded by the arm. That might get rid of that sound. And this is the problem with a very low output cartridge. And for a very powerful amplifier, if there's any nonsense, the nonsense is going to come through. Yeah, I think that's the next step. Replace this properly and get rid of this unnecessary unshielded situation here. Okay, so you can see I have a strobe on top of the record player. You can see my camera is going nuts. These kinds of patterns throw the focus system way off. It can't handle it. Now it's handling it. So I have a camera poised here to look down at it. This is what you see. But the thing about a camera is it's got a shutter action, sort of like a shutter action in it. So just exactly what you're going to see, I don't know. And I have a neon light here ready to shine. A neon light. The neon light is going to go on and off at 60 hertz. So let's give this a go here. Just get this running first. Okay, we're on 33. There we go. And you already see in the camera, you can see some strobe actions happening already, and I think that's from the camera. So the one we're looking at is this one here. So if we think the camera is going at 60 hertz, which is possible, it's in 59.95 or something crazy like that. Maybe we already have an indication that it's slow. But let's add in the neon light here. Now, I don't want to get a shock. I think I need to turn off certainly this light here. Okay. You know, even the LED lights I'm using in here may be flickering at 60 hertz. Okay, so I'm going to bring over, I gotta switch it on here. There we are. Let's hold it there. Well, this suggests it's running. Well, that was funny. What happened there? I better look with my own eyes, not look in the camera. Okay, so when I look with my own eyes, it's going slow. It doesn't look very slow at all. A little bit slow. But the thing is, we need to have the cartridge on the record to do this properly. So, okay, I'm going to drop it on the record here. So, you know, this suggests it's a little bit slow. It looks very similar to what you're seeing in the camera. It's not slow enough to worry about. Now, what can we do about it? Some record players have speed adjustments. This one doesn't. The only thing, let me just lift this up here, see if it changes. Didn't really seem to change. Let me do the finger drag thing. Okay. So I'm going to drag my finger on the platter. Maybe you can see it slow down a bit, but that's a fair bit of pressure on there to do that. So what would make it run slow? Let me get rid of this neon bulb here. Well, it could just be slow because the motor's weak and all that kind of stuff. But that's not very likely. A motor is designed to spin at a very fixed speed. It's a synchronous motor, I imagine. And another possibility is slippage in the traction, but I don't think there is because I put my finger on there and it didn't really slow it down much, so I don't think it's slippage. The most obvious thing is the spring I put in is pulling hard, and that's pushing the spindle of the motor kind of over, right? It's pushing on the spindle quite strongly. And the motor bearing, the spindle bearing in here, may be taking a little excessive pressure, a little excessive friction in there. Will slow it down a wee bit. So the trick to that would be, okay, we seem to have some excess traction. Loosen up the spring a little bit and see what happens. Is this really enough to worry about? Is the spring really so strong I should worry about it? I don't know. I'm going to think about that. Okay, I'm going to check out that spring again. Take a look. First thing I want to do is try to assess how hard it's pulling. So we got the power off here, and yep. Let me unplug it so it can't catch me by surprise. Okay, we'll put it into operating mode and that'll pull tension on the spring. How much tension is that? Well, you know what? That is quite a bit. That is definitely quite a bit. Thinking about how loose the original spring was, it made this record player work with a very light amount of pressure. Of course, that was with the... Wow, you know, this wheel still feels hard. Okay, let's just see if we can loosen this off a little bit. I'm going to try to stretch it here. This is kind of a one-way trip doing this. Can't unstretch it. This is also spring metal, which means stretching it isn't necessarily the easiest thing either. You have to stretch it a long ways to get it to get it to strain. I think I already did. What I did was I opened up the loop here is what I did. Still pulling pretty hard. Let's leave it stretched here. Stretch this last link here a little bit. That's quite a bit. Uh-oh, I'm going to have a problem with the spring falling off. Yeah, I think I'm into a new problem now. Dropped right off. So that's part of what goes on when you're working on these old things. anything really, is you try to solve one problem, you introduce another one. Yeah, see, it's not going to fall off here, but it's always going to drop off this one. Let's take a look at this. So what I do here, and make it longer and make it shorter at the same time. If I squeeze this down, it can't slide right off. I think that's the trick. Make the end loop smaller. I don't know how to do that. Crush it. Yeah, I don't know how to do this. I do not know how to do this. I crushed it. Let's see what we got now. It's not going to fall off. Pop on. Okay. It's like accelerated life testing. Accelerated life testing. Here's a dumb idea. It's like saying, we want to know what this does to people who are 70 years old, but we're scared to do it with people who are 70. So we'll find some people who are 40, and we'll have them run around a track for 20 minutes. Then we'll pretend they're like 70-year-olds, and we'll test them. But they're 40-year-olds who ran around a track. This type of cable was introduced to the power industry in the late 1960s, called high molecular weight polyethylene, and other types of polyethylene insulation. It was displacing a very different kind of insulation, and there was concerns that, well, how do you know this stuff's going to be any good? I mean, I'm going to build a cable and run it for 100 years and see what happens? Well, no, we're going to do accelerated life testing. So they took samples of the cable, heated it up in water baths, did various things to, quote, turn them into 70-year-olds, and then test them. The result of that testing was the cables would function for 1,000 years. In other words, a perfect life. I mean, 1,000 years is ridiculous. So if they're not going to fail within 1,000 years, they're never going to fail. Those cables got installed widely in the United States, not quite so widely in Canada. In the United States, they were used as secondary supply cables, underground to people's homes and small buildings and stuff like that, very extensively, direct buried in the ground. In Canada, some high voltage cable was built using a cross-linked polyethylene cable, which was also expected to last the 1,000 years. The 1,000 years. So the high molecular weight polyethylene turned out to have an 8 to 10 year life, and the cross-linked polyethylene turned out to have a 10 to 12 year life before developing a problem inside with dendritic growth. 1,000 years. When you take the 40-year-old and run them around the track, that's what you get. Hey, 1,000 years. Well, I guess that's a little lighter. Doesn't feel. Yeah, definitely it's lighter. It's still pretty strong, but I want it strong. I don't want it too weak. Now I did oil this guy. Let me give him a little more oil just to make me feel better. Small amount of oil. Oh, I think I just got oil on the side of the. Got it on the side here, I think. I'm not sure if I really did. I guess somebody could be inclined to try to rough up these surfaces too, which are probably somewhat polished. This brass surface here. Never tried that myself. Rough it up, get more traction. But well, the question is it going to run at a faster speed with that? How much change is that? I'd say it's about 70% of what it was. Maybe even 60% of what it was. Let's give it a go. It's engaged. So I think I can feel the tracking, anti-skating force here. It certainly felt like I could feel something. In my imagination. That's all I'm feeling. Okay. Let's put on the record and the strobe. Okay, put her in, get her going. Down with the lights here. And what did I do with my very fancy neon bulb system? Now I'm not plugging this neon bulb into 120 volts, by the way. I have the output voltage turned down here to whatever it is, probably just above 80, probably. Make the neon bulb come on. Let's make that neon bulb come on. Come on, bulb. So I will get the other camera here. Switch to it. interesting. So this is the one of interest, and in the camera you're seeing it go fast, but that's a false. That is false. It is going about the same speed slow. Now, how slow is that? How can I tell how much faster this would have to go to like, for instance, if I put this on another record player with an adjustable speed, and then I could have the speed correct, listen to the music, and I could slow it down to this speed and listen to it, and so, you'd hear the speed go down, so you'd know, oh, that's how much. Pretty tricky here. I might be able to fool it by moving the speed control up a bit. Let's just see what happens again. I know here. So, no, not on this player. In this player, it's going to pull off. Yeah, see, it's pulled off the drive wheel. Yeah, I don't think we're going to get anywhere. Let me check the traction here. Traction's a little bit less, I think. Hard to tell. There's two things could be happening. I'm dragging my finger on the platter. Two things could be happening. One is I'm slowing the whole thing down, including the motor. Everything is slowing down, which is what I think is happening. Or I'm introducing slippage. Something is slipping somewhere. It would be like a traction here, but let's put the needle on here. I almost dropped it on the record. And what you're seeing is not what I'm seeing. Here we go. So you cannot make out that there's any speed change. Something that would happen, since there's a little bit of momentum in the record player, if it didn't have much power, let me just turn this off. If it didn't have much power driving it, and you put the needle on and that's enough drag to slow it, you would hear the slowing in the sound. It would start quick because there's momentum in the platter, and you would hear it. I didn't hear anything like that. I think this is it. I think it's going to be a little slow. Well, I did perform that experiment I was describing. I went to my own turntable, my own stereo. You had a record on there. I put the strobe on, and what I got was my turntable turns just a little bit fast. It doesn't have a speed control, so I couldn't adjust it. So this record, what's going on with this record? Looks like it's been lathed. Yikes. Okay, let's just put on this side. So what I did was I just put my finger on the rim to slow it down a bit, and to try to get the change in the speed of this, which is going slowly forward, to be going backwards just a wee bit, imitating the speed here being too low. And the result is it's very distinct. If you do that, the pitch change is very distinct, but then, we're human beings. We're extremely sensitive to that kind of stuff. The question is, if you just walked in and listened to it, would you go, hey, that's slow? Now, I did get an email from somebody who said, hey, that's slow. So maybe some people can figure it out. This is a piece of music that I'm very, very familiar with. I'm going to play this. I'm going to do most of this off camera so I don't get a copyright hit. But we'll just let the very start go here. I haven't changed the chord yet. You know what? That's all I got to hear. That's definitely slow. I'm very familiar with this piece. It's definitely slow enough to bug me and bug anybody. Oh my gosh, what else could be going on here? If you're thinking it's you ground down the intermediate wheel, that's slowing it down. No, that won't slow it down in itself. There's some way I could rig up a situation where I can pull off the tension. There you are right there. Pull off the tension. Okay, I got an idea. I'm going to try something a little kooky here. I'm going to take the kooky comment back. It's not kooky. I can reach up under here, grab onto the mechanism a little bit, pull on it, and release the tension by pulling the wheel back. So I can imitate a weaker spring just by doing that. So we're going to try this. What I'm looking for is a variation in the speed. You know something else I haven't done yet? Maybe I should do it right away. I haven't even tried the other speeds. Are they all the same? Are some of them fast? Could that even be? How could that be? I don't know, but let's find out. Okay, so I'm just going to leave that camera on because this isn't working so well anyway. On the other camera, there we go. Okay, so there's the 33. Going this way very slowly. Okay, we're going to jump the speed up. I don't really care about the 16. Jump the speed. Well, it's not the speed. Where'd it go? Here it is. Working in the dark. So this is now 45. So guess what? 45 is right on the money. If anything, it's going ever so slightly fast. You know, you're kind of seeing it there in that camera. Yeah, you're seeing what I'm seeing. So we'll go to 78. How about you, Mr. 78? Listen to the record player. It's a rock solid. Back down. Whoa, 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 whoa. Come on here, stay on there. You can't get much closer than that. From 45 down to 33. 33 running slow. Now we're down to 16. That's really curious. So 16, I don't know if you can see that in the camera. Not really. It's interesting. This one, am I doing this right? Was I looking at the right thing? I wasn't. Just a sec. Stop this baby. Stop, stop, stop. Yeah, sure. 78, 45, 33, 16. Yeah. Back on. 16's a slow poke. So 16 appears to be slow. Well, not really. But it's just 33. What's that saying? 33 again. Touch slow. 33 and a third is the actual speed. 45 is right on the money. 78 if you care to. Right on. Oh, I'm glad I did this. What am I chasing? Wow. You know, a possibility here, although I think it's very, very remote, is the spindle itself has changed dimensions by, you know, playing many 33 and a third records. That's just hard to believe. Turn this off. Okay, you know what? I don't think there's any mileage I can get out of this to change its speed. Oh no, I was going to do the take the tension off test. Yeah, we should do that. We should try that experiment. Right, and I'm going to do this. I got to do this off camera. I can't do it on camera. Okay, so it looks like I thought I was recording when I wasn't, so I'm going to turn this guy back on. I'm going to re-explain what I'm doing here. We have the record running. I'm going to put the needle down. We're going to listen to it. I'm going to reach underneath, and I'm going to slacken off the pressure by moving the mechanism from underneath on the intermediate wheel. If the pressure of the intermediate wheel is slowing things down, then what we will hear is the speed coming along. The speed will increase and then drop off, because at some point I'll be disengaging I'll be ruining the traction. So we're looking for it to go up and then down. This is a bit of a crude thing, and I got to edit this so you only have about just a few seconds of this while I do this. Here we go.
I'm going to find a way to become what I am. I'm going to find a way back home.
Okay, here we go. So I would say the wobbling like this, because it's up on these stilts and whatnot, the wobbling sound, which would be called a flutter, is literally from the mechanism's various frictions varying as you move it around, especially the motor bearing and stuff. That's what I would say then. Ooh, I don't know. Who knows? I don't know. Okay, so the conclusion here. First, I got to put on the other cord and try to get rid of this sound. Conclusion here is barking up the wrong tree. Spring tension is not slowing this thing down. When I lifted the pressure off, and I did this quite a number of times now, it always just slows down. It never goes through a pickup of speed. So, and we saw the other speeds are correct pretty much. It's really, you know, maybe this isn't as precise as one would think. Okay, now for the cord. Okay, if we take a look at the wiring here, the audio cable, there's two phono plugs right here. Hey, what's that all about? Wait a minute. Wait one cotton picking second. There's an easier way of doing this. I'm going to take this very long wire and just cut it and solder it, because I just thought, I didn't realize these are here. Of course, this is a stereo record player. Maybe someday it has a future in some other receiver. Let's just get rid of all this nonsense then. Goodbye to it. So what I can do here, again on the basis of being easily reversible, get rid of that. So the way they have these, the two hot or signal ones are these two terminals here. The two outside terminals are ground. Either one of them would do. All I gotta do, that's because I'm still thinking about soldering a wire here. All I gotta do is just short these two guys together here, and then plug a single cable in here and plug the other end over yonder. We're done. Pull this off. Got a nice piece of wire there. Let's get these cartridge wires out of the way. Don't burn them with a soldering iron. Just do this. Little piece of wire there. Just twist these. I don't even have to solder this, but I will, of course. This white wire is just right there. Okay, we'll solder that up. Boy, I almost missed that, didn't I? And we could try this long cable. If it does the trick, that's good. A little extra cable won't hurt necessarily if it's shielded well enough. Or we could just get a shorter cable, mono cable around. So I'm just waiting for Mr. Soldering Iron to get hot. Where are we here? It's almost 2:30 in the afternoon now. I've got this rather thin solder here. Left my soldering iron turned up from what I was doing earlier. Let me turn it back down. Yeah, first thing I do is burn one of the little wires. Pretty sure that's soldered. Okay. Not so sure. Yeah, that's soldered. Okay, so that puts the two channels together. All I need to do is just, oh, I got the cord right here. Let's test it out. It's a long cord. Very long audio cord. So I'm going to cut this off. Let's plug it in open-ended. It's kind of a dumb thing to do, but let's do it for fun. On the excitement, I have to have this turned upright to really find out, don't I? No, I don't. No. Okay, look at the old. Get out the old. In with the new. Grandpa didn't do this part quite so good. I guess when the new record player was put in, it required some of this kind of effort, and he didn't do quite so good on that. Okay, plug this in. Oh no, we're going to try it open first, just to hear what it sounds like, just for a lesson. I need a lesson. Okay, let's turn it on. So with this wire unplugged, it's rather like an antenna. What did I do at the end of it? It's a little like an antenna. Turn up the volume. Way less than it was. Way less than it was. Okay, I didn't say it was a good antenna. Now we're going to plug it in here. I've turned the volume down while I do this. Volume up. Okay, picked up a little more noise. Because of that. Just this wire here. Where it's close, it's close. It's not so susceptible. Can you see what I'm doing? Watch this. So I'm an independent electrical thing here in my shop. I got rubber-soled slippers on. I'm floating in space, basically electrically. So I'm an antenna. And what kind of signals are in me? Well, everything under the sun, but in particular 60 cycles from the house. If I bring myself close to the antenna, you can hear it. Well, what happens if I ground myself? Isn't that interesting? I think it's interesting. Okay. Flip this guy over and we're going to play another record. So ready to try again. Now I have my beloved record on here, but this is an American or North American pressing. Could have been done here in Canada. Yeah, I have another copy of that record that my sister brought back from England for me when I was a young teenager, and it's a British pressing. Thumbs up on that. It sounds way better. I don't know exactly dynamic range. I don't know what it is, but the record sounds way better. Unfortunately, I damaged one side of it a long time ago, so one side is messed up. But okay, let's hear it for British sound. Let's hear it. for British record player. British, is that the right word for it? Never know. Okay, it was already going. So I got to turn way up to hear that sound now. Better work. Okay, so in that piece of music I was just playing, there are some long-held notes, probably done with an organ, and they're steady. They're very, very steady sounds. So you can hear if there's any wow in the record player or any flutter or stuff like that. There's a little bit in there, but what do you expect? Can't be perfect. I mean, this is a rim drive record player, so it's not belt drive, it's not direct drive. It's a rim drive. They only get so good, but as far as rim drives go, this is a very good one. Okay, where am I at now? Where am I at? I'm now at the point of getting to listen to this with the speaker back in the cabin. I think that's for tomorrow. I think I'm going to cut this off right here. What is that? What is that? Okay, someone's probably may have answered that question in a comment, by the way. And if you have, thank you very much for answering that question as to what that is. Okay, there we go. Thanks a lot for watching, and tomorrow I should wrap it all up, I think.